In this question, you are given a graph that shows the height of the falling object changes with time. And since it's a height, you know that it's basically a length and it's also a distance. So this is basically a distance time graph. You can see it this way. And you should know that the gradient of a distance time graph will represent the speed. Now let's start with understanding the graph. So at time equals to 0, the height is 4. So why is it 4 instead of starting from 0? So that means to say the reference point is on the ground and the ball right now at time equals to 0 seconds, the height over here is 4 meters. That's what it means. So that's why it has a displacement already, which is 4 meters from the reference ground. Next, there are basically two sections. You can, if I were to highlight here, this portion here is considered the first section, and then this is the other section. So based on what you have previously learned from distance time graph, you know that the gradient is getting steeper and steeper. So this is increasing speed. And here onwards is a straight line with constant gradient. So it's constant gradient, constant speed. So that means to say the ball is falling with increasing speed, then up until 1 second, time equals to 1 second. From then onwards, you'll fall at constant speed all the way just before it hits the ground. Maybe if I were to draw the speed time graph, then you'll be very familiar, because initially when you let go, the initial acceleration you let go, it will be 10 meter per second square free fall. So it will be like that. So since the speed is increasing, it will continue to increase, but it's decreasing acceleration, but the speed is still increasing. Then from then onward, it starts to move at, from 1 second onwards, it starts to move at terminal velocity. It's like a maximum constant speed, so it will look like that. So I believe many of you are familiar with this speed time graph, and this is actually the respective distance time graph. So if you understand the portion that is highlighted in red, this is where the terminal velocity happens. And if you want to find the terminal velocity, you basically look for the gradient. And since it's a straight line, you can just take basically any 2 points on the graph. So to make it easier, I'll just take this 2 point. Okay, so the terminal velocity, which is the gradient, which is your y2 minus y1, x2 minus x1. So it will be 2 divided by, and the time interval here will just be 1. 2.5 minus 1.5, so it's 2 over 1, so it's 2 meter per second. Okay, so that will be the terminal velocity. So the answer will be D. Maybe another thing to add is, as it's falling down, you can see that the distance that is measured from the reference point is decreasing. That's why it's decreasing until just before it hit the ground, the displacement will be 0. So I hope you understand the question now. Thank you.